Hey guys, in today's lesson, we're going to talk about graphs of sine and cosine functions, which is found in section 4.5, part 2. Our objectives are to use amplitude and period to sketch translations of sine and cosine. All right, so just to remember, amplitude is similar to the range of the graph and is found as the absolute value of the coefficient of the function. And usually we say it's the coefficient. Didn't mean to do that. It's the absolute value of that a, which a is the coefficient of the function. For the period is a full cycle of a function. It is found by dividing 2 pi by the coefficient of x. So 2 pi over the coefficient of x. Okay, so we'll put that into work in this problem here. So let's look at example 3. In example 3, we are focusing on horizontal stretching. So as a reminder, the amplitude is the coefficient. The amplitude is actually just the a value. And our a value here, or the absolute value of our a, is 1. Okay? So then that means our range then is from -1 to 1. So that helps me with graphing. Then also, our period is the coefficient of x. So this is going to be 2 pi divided by 1/2. 2 pi divided by 1/2 is the same thing as saying 2 pi times 2 over 1, right? The reciprocal of the denominator, which is then going to give us 4 pi. So it's going to take a full 4 pi to make a full cycle. So let's take a look at what that information means. All right, so if the period is 4 pi, you have to go at least as far as 4 pi. So we have negative pi over here. We have pi, 2 pi, 3 pi, and 4 pi. When we're done, that's where we're supposed to end up. Okay, so normally, and I'm going to do this in a different color. Normally, if I were just doing regular old sine, like sine of x, right? And this is 1 and -1, by the way. Normally, if I were just doing sine, then sine of 0 would be 0. Then we'd have at pi over 2, we'd have 1, and then it go back down to 0. And then at 3 pi over 2, we would have -1 and then go to 2. So it would look something like that. Or I missed it at the bottom, but you get what I mean. But since it has shifted, these 4 values kind of got stretched out. Okay, so what that means then is we really don't focus on those values. We still have sine of 0 is 0, okay? But now we just answer for pi. So essentially, for pi, at pi, let's draw it out. At pi, it's not exactly the same as what at pi, you essentially just move everything over. So whatever was at pi over 2 is now at pi, because I'm taking these and I'm breaking them up into 4. So this now goes here. At 2 pi, it's now back at 0. At 3 pi, it's down at -1. And at 4 pi, it's back at 0. And then at negative pi on the other side, it's down. So because it has been stretched horizontally, it's going to kind of take on this shape here. So again, notice what the original period would have been at 2 pi, but because it is pi over 2 and the period has been stretched to 4 pi, everything kind of got shifted over quite a bit. Okay, with try 3, we have a similar situation, except this time it is cosine. Okay, let's write the information that we know. So the amplitude, didn't mean to be in highlighter. Okay, sorry, the amplitude will be the a value, and our a value is 1. So then that means our range then is from -1 to 1. And then our period will be the coefficient of x, which is 1/2. So, the period then would be 2 pi divided by 1/2. And we just did that 2 pi divided by 1/2 is 4 pi. So again, we got to stretch this out quite a bit. So we have negative pi over here, pi, 2 pi, 3 pi, and 4 pi. Okay, at +1 and -1, we typically, if it's cosine, and I'll give you again the typical values, typically we would have a 0, and then at pi/2, which is halfway in the middle, it would go down, then it'd go down to 0 at pi, then it'd go back up to 0 at 3 pi/2, then it'd go up to 2 pi. However, because it has been stretched, our values kind of take on a different shape. Instead, I have a value at 0, and again, let me go ahead and sketch the original cosine function. So it normally looks like this, right? But it has been stretched vertically by the pi. So at 1, then at 0 for pi, then at -1 for 2 pi, at 0 for 3 pi, and then at 1 for 4 pi. Again, on the other side, it would go back down to 0. So this, for this function with the horizontal stretch, would actually look like that. All right, let's keep going. So our vertical translations I already mentioned deal with D. So if D is greater than 0, it shifts upward. If D is less than 0, it shifts downward. So that is essentially like your up and down translation. It's not too bad. The main thing that you want to understand is that y equals D is the horizontal line that the graph oscillates rather than the x-axis. So in other words, it does not curve around the x-axis anymore if you have the variable D present. So instead now it curves around, or you have a sine or cosine curve around whatever your D value is. So let's look at what I'm talking about. So it says y equals 2 plus 3 cosine of x. So for us, our amplitude, or our amp, sometimes we say that, our amplitude is the A value, which is 3. Okay. We'll come back to something else. The period would be 2 pi over the coefficient of x. The coefficient of x is 1, so our period is 2 pi, so this is a normal one, which is nice. However, because I have this 2, my range is not from, normally if the 2 hadn't been there, my range would be from -3 to 3, right? However, since my 2 has been added, I have to add 2 to both of my range, or both the values of my, or the endpoints of my range. So if I add -3 plus 2, I will now get -1. If I add 3 plus 2, I get 5. So now we're going to create that graph. Really, I need to create that just a little bit lower. Okay, so if my graph is from -1 to +5, 1, 2, 3, 4, 5. Remember, at 2 is now my x-axis. 2 is now my x-axis. So I'm just going to draw an imaginary line to help me as I'm trying to graph. Okay, since 2 pi is my period, I can make this just a normal graph, right? I can make this -pi. This will be -pi over 2, then pi over 2, pi, 3 pi over 2, and 2 pi. Okay, let's get started with the graphs. So at 0, cosine is typically 1, but since I had to, it's typically 1, but in this case, we're already at 2. Okay, let me say this accurately. Okay, typically at 0, just a regular cosine of x, I would have 1. However, that 1 has then been multiplied by 3, which gives me 3 as my value, and then I have to add 2. So cosine of 0 for this function will actually be at 5. Okay, so if you think about the shape, you'll see it in just a second. Cosine generally at pi over 2 is 0, 1. So cosine is typically 0. However, it's going to be 0 times 3, which is 0, and then plus 2 will give you 2. So it ends up being there. At pi, our cosine is -1. But if you multiply it times 3, that's -3. But if I add 2 to that, I get -1. So now it's dropped down here. If you can see the pattern, at 3 pi over 2, it's going to go back up to 2. And at 2 pi, it's going to go up to 5. And then on the other end, at negative pi over 2, it goes down to 2. And then way down to 0 for negative pi. Sorry, not 0, but -1. Okay, so this graph is going to take on this shape here, and I forgot the 2 pi. The 2 pi is going to be back up here. Okay, again, it's no longer oscillating or curving around the x-axis because it has been shifted up by 2 units. Okay, last one, we're going to graph the function y equals 4 plus sine x. Okay, so again, we want to talk about some particular information. So the amp is the a value, and our amp is 1. Typically what that means then is that our range will be from -1 to 1. However, because it has been shifted up 4 units, you need to, for each endpoint, add 4. So -1 plus 4 means that this is going to be from -3 to 5. That's going to be our range. And our period will be 2 pi over the coefficient of x. And, the coefficient of x is going to be 1, so it's just 2 pi. So again, we're back to a fairly normal sine curve. So this is pi over 2, pi, 3 pi over 2, and 2 pi. I know it's really stretched out, but I need to give myself a little bit of room with this stylus. Okay. And again, our range is from, oh wow, I made a mistake, didn't I? -1 plus 4 is +3, not -3. Okay. Sorry, it's from +3 to 5. So I need to give myself more space up here. It says 1, 2, 3, 4, 5. At 4 is now my new x-axis if I want to think about it like this. So at 4, which is right in here, that's my new x-axis. So from there, I just plot what I would know to be the sine curve. As a reminder, sine of 0 is 0, but then if I multiply 0 times 1, I still get 0, but I have to add 4 to that, and I get, I add 4 to that, and I get 4. So in other words, I'm starting on what would be the x-axis, but now it's been shifted up 4. Sine of pi over 2 is 0. Sine of pi over 2 is 1. 1 times the 1 would give you 1, and then 1 plus 4 is 5, so it goes up 1. Following that curve, it goes back down to 4, then down to 3, then back up to 4. On the other side, it's down at 3. So this graph takes on this shape here. So this one's been stretched pretty well. And then not only has it been stretched, but then it also kind of got shifted up. I won't say it actually really got stretched. It only looks stretched because I spaced my graph out pretty far. But generally, this is actually like a regular curve. All right, guys, that's it. If you have any questions, again, please be sure to come see me for tutoring.